Hello viewers, you're welcome to our online class today. Today we are going to be looking at Newton's laws of motion. Okay, Newton has 3 laws of motion that we are going to be looking at today, and we'll start from the first law, which is commonly called the law of inertia. It's commonly called the law of inertia, and what did it state? It states that a body at rest or in uniform motion, that is, let me explain, if a body is in a particular place or point, that body will remain in that particular place or point except there is a force that is going to make the body to change its position. Or if a body is already in a uniform motion, that is, a body is in a uniform motion, that body will continue to move in that pace except there is an external force that is going to halt it or reduce its motion or increase it, as the case may be. So that is what the law of inertia, or the Newton's first law of motion, is trying to explain. So in stating it, we say that a body at rest or in uniform motion will continue to be in its state of rest or of uniform motion except it is being acted upon by an external force. I repeat, the law of inertia, or Newton's first law of motion, states that a body at rest or in uniform motion will continue to be in each state of rest or of uniform motion except it is being acted upon by an external force. So that is what the first law states. And the second law of Newton has a mathematical relationship. That is where Newton said that the rate of change in momentum of a body is directly proportional to the applied force on it and acts in the direction of the force. The rate of change in momentum of a body is directly proportional to the applied force and acts in the direction of the force. It has a mathematical relationship. Mathematically, the rate of change in momentum is mass times velocity. So the change in momentum is mass times velocity minus another mass times velocity. And you know, in motion, we represent two velocities, the initial and the final velocities, with u and v, where u is the initial velocity and v is the final velocity. So the change in initial momentum and the final momentum is what you refer to as change in momentum. And whenever you hear rate of something happening, it means the time factor of that thing, that is, that thing happening with respect to time. So the rate of change in momentum is the change in momentum with respect to time, that is, change in momentum divided by time. So the rate of change in momentum is directly proportional to the applied force. Now, from our statement, one would say that if you say the rate of change in momentum is directly proportional to the applied force, this is the way it is going to be written. That is mathematical variation. But the reason why we are writing it like this is because it is force that will cause a body to change its velocity, and then there will be a change in momentum. Are you getting that? So because of that, it is force that will cause a momentum, the rate of change in momentum. So it is force that is going to be varying, or that will lead to a change in momentum. That's why force is coming first. But by definition, we say that the rate of change in momentum is directly proportional to the applied force and acts in the direction of the force. So this is relationship in Newton's second law. And we know that in variation, if we change this proportionality sign to an equality sign, we introduce a constant. And because the same body has this mass and this mass is the same mass, so we can factor out the mass and then put the change in velocity in brackets divided by t. Okay, and if our constant k is taken to be unity, that is taken to be 1, if the constant k is taken to be 1, then the force is equal to mass times change in velocity all over time. And we recall that change in velocity over time is acceleration. If that is the case, one can simply say that force is equal to mass times acceleration, and that is where we go to this simple mathematical relationship where force is the product of mass and acceleration. Of course, we should know that This is about the Newton's second law of motion. So we use this to solve series of questions in WAEC, in JAMB, and other exams and other applications in physics. Okay, that is about that. While the third law states that action and reaction are equal but opposite. What does that mean? That to every action, there is an equal and opposite reaction, like in the recoil of a gun. If you have a gun, and if you fire a bullet out of the gun, you realize that there will be an opposite force, that will be a force pulling the gun backwards. That is an equal and opposite force. That is, to every action, there is an equal and opposite reaction. If you slap someone, though you are applying a force to inflict a pain in that person, but there is also an opposite reaction that is acting on your own terms. So there is always an equal and opposite reaction to an action taken. That is the third law of motion. I am going to recap it so that it will sink. The first one is what we call the law of inertia, which states that a body at rest or in each state of motion will continue to be at rest or in each state of uniform motion, except it is being acted upon by an external force. The body at rest or in uniform motion will remain in each state of rest or of uniform motion, except it is being acted upon by an external force. While the second law, it states that the rate of change in momentum is directly proportional to the applied force on it and acts in the direction of the force. That is this second one, which we have represented mathematically, and we was able to derive it to force equals mass times acceleration. While the third law states that action and reaction are equal and opposite. Alternatively, you can say to every action there is an equal and opposite reaction. That is about Newton's laws of motion. And just as we have discussed these laws, there are terms that we need to know that are associated to Newton's laws of motion, so that as we are expressing those terms, we will all know what they actually stand for, such as inertia. We have mentioned inertia to be the first law of motion. But what is inertia as a word? What does it mean? Inertia is the reluctance of a body to change its state. That is the tendency of a body to want to remain in its state of rest or of uniform motion. That is, if a body is at rest, the reluctance of that body from trying to move is what we call inertia. That body refusing to move, the ability of that body to want to remain in its state of rest or of uniform motion is what we refer to as inertia. Okay, then that means that the inertial mass is that mass possessed by a body that will make it to maintain its state. The higher the massive a body, the higher the inertia of a body. If a body is very heavy, there is a tendency that it will remain there. That is, it will require a very great force to move it from its position. But a light body will just need a little force and it will change position. So the inertia of a body increases as its mass increases. Okay, other terms that we need to know as we are discussing Newton's laws of motion are linear momentum of a body. Linear momentum of a body linear momentum of a body is simply the product of the mass and velocity of that body. The product of the mass and velocity of that body. Momentum, we can represent it with this, is equal to the product of the mass and the velocity of the body. This is what we will refer to as linear momentum of a body. Another term we have is the principle of conservation of momentum. The principle of conservation of momentum The principle of conservation of momentum states that in a closed or isolated system, that in isolated or closed system of body, the momentum of the body before collision is equal to the momentum after collision. Or in a closed isolated system of a colliding body, the net momentum is a constant. So let's look at this question under this law. It states that a bullet of mass 120 gram, I always advise we list our parameters. Mass M is 120 gram, which is converted to kilogram. You divide by 1000, you have 0.12 kilogram. Okay, is a bullet of mass 120 grams is fired horizontally into a fixed wooden block with a speed of 20 meters per second. That is, the initial speed u is 20 meters per second. Okay, if the bullet is brought to rest in the block in 0.1 second, okay, the time is 0.1 second by a constant resistance. Constant resistance is brought to rest by a constant resistance. This resistance is a force. Okay, so we can say it brought to rest by a constant force. Calculate the magnitude of the resistance. That's the magnitude of the force. Okay, if you look at this, if a body is brought to rest, that is in motion, you should know that if a body starts from rest, it means the initial velocity is 0. If a body comes to rest, if a body that is already in motion now comes to rest, it simply means that the final velocity is 0. And you know, initial velocity will represent with u and final velocity will represent with v. So in this scenario, they said that the body came to rest. That means that the final velocity is 0. Okay, so if we use our relationship, we say that force is equal to mass times acceleration. Okay, where acceleration is the rate of change in velocity, that is change in velocity over time. Okay, and if we apply that, we know that is 0 minus is 20 divided by our time is 0.1. Okay, and that is going to give us minus 200 meters per second. Okay, it is minus 200 meters per second because what happened is not acceleration. What happened is deceleration. There was a decrease in speed. That is why the body came to rest. So if that is the case, the deceleration or retardation is equal to 200 meters per second squared. Sorry, per second squared. That is the deceleration or retardation. So this negative is only indicating that there was a decrease in speed, not an increase in speed. Therefore, the reluctance, the resistance, the magnitude of the resistance or the force is going to be mass times acceleration, which is 200 meters per second. So the force is equal to, the mass here is 0.12 kg, then you multiply it by 200, and that is going to give us 24 Newton. That is the force. Okay, that is the reluctance or release, the resistance, 24 Newton. Then the second question said we should calculate the distance moved by the bullet in the wood. The distance moved by the bullet cannot be gotten from this formula. We go back to the equations of motion. Remember, this is still a motion, a linear motion. So we'll go back to equations of motion. Okay, the three equations of motion, we have v equal to u plus at, we have v squared equal to u squared plus 2ax, we have s equals to ut plus half at squared. So it depends on the one, we have the parameters complete. Okay, we have the initial velocity, we have the time, we have the acceleration, which we have gotten. So we can use v squared equal to u squared plus 2as. Okay, so if that is the case, if we are to make s the subject of the formula, we are going to have 2as is equal to v squared minus u squared. So s is equal to v squared minus u squared all over 2a. So when we substitute in this formula, we have that our s is equal to, the final velocity is 0, remember, we have 0 squared minus, the initial velocity is 20, so we have 20 squared all over 2 times the acceleration. And what we got the acceleration is 200, so you multiply by 200. So this is going to give us 20 squared is 400, so you have minus 400 all over, of course, we can ignore this minus because the indication is that there is deceleration, we know that. So 2 times 200, we also have 400. So the distance is 1 meters. Okay, so we see how we did that. we are going to see more of the questions on this topic in our next class. Thank you.